Hey guys, we're going to learn about multiples today, but as a way to review, we're going to watch a Khan Academy video on finding factors and multiples. It's only 3 minutes, so we're going to watch this video and then we are going to do our new lesson on multiples.
Which of the following numbers is a factor of 154? So a number is going to be a factor of 154 if we can divide the number into 154 and not have a remainder. Or another way of thinking about it, a number is a factor of 154 if 154 is a multiple of that number. So let's look at each of these and see which of these we can rule out or say is a factor. So does 3 divide evenly into 154? Or another way of thinking about it is 154 a multiple of 3? Well, you'll later learn that you can actually test whether something is divisible by 3 by adding up the digits, and if that's divisible by 3, then it's going to be divisible by 3. And so you see here 1 plus 5 is 6, 6 plus 4 is 10, 10 is not divisible by 3. But if you didn't want to do that little trick, and we have other videos where we go into more detail about that trick, you can actually just divide 3 into 154. 3 doesn't go into 1, it does go into 15, 5 times. 5 times 3 is 15, subtract, then we have 0, then you bring down a 4, 3 goes into 4, 1 time, 1 times 3 is 3, subtract, and you have a remainder of 1. So 3 is clearly not a factor of 154, so we can rule that out. Now what about 5? Well, any multiple of 5 is either going to have a 5 or a 0 in the ones place. You see that. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. You either have a 5 or a 0 in the ones place. This does not have a 5 or a 0 in the ones place, so it's not going to be divisible by 5. 5 is not a factor. 154 is not a multiple of 5. Now 6 is interesting. You could do the same thing. You could try to divide 6 into 154. But if something is divisible by 6, it's definitely going to be divisible by 3 as well, because 6 is divisible by 3. So we can immediately rule this one out as well. Because 154 is not divisible by 3, it's also not going to be divisible by 6. And you could try it out if you like. And we would make the same argument for 9. If something is divisible by 9, it's going to be divisible by 3, because 9 is divisible by 3. Well, it's not divisible by 3, so we're going to rule out 9 as well. So we've ruled out everything. It looks like 14 is our only option, but let's actually verify it. Let's actually divide 14 into 154. 14 doesn't go into 1. It goes into 15 exactly 1 time. 1 times 14 is 14. We subtract. We get 1. Bring down the 4. 14 goes into 14 1 time. 1 times 14 is 14, and of course we have no remainder. So 14 goes into 154 exactly 11 times, or 11 times 14 is 154. 154 is a multiple of 14. Let's do one more. Which of the following numbers is a multiple of 14? So now we have 14 and we're trying to think of its multiples. So there's 2 ways of doing this. You could go number by number and try to divide 14 into them, or we could just try to figure out what all the multiples of 14 actually are. So let's try to do that. Let's try to do that second technique. 14 times 1. 14 times 1 is 14. You add another 14. 14 times 2 is 28. Add another 14. Let's see, you add 10, you get to 38. Then you add 4 more, you get to 42. Then you add another 14. I haven't seen any of these numbers show up yet. Add another 14 to this, you get to 56. Still not quite there. Add another 14. Let's see, if you add 4, you get to 60, and then you have to add the 10, so then you get to 70. And it looks like we have found one of these numbers. 70 is a multiple of 14. 14 times 1, 2, 3, 4, 5. 14 times 5 is 70.
Okay, so now that we did that little review of factors and multiples, we're going to move on into our lesson today on multiples. Let me get my ladybug working. There we go. Open it up. Okay, so you can also watch on Brain Pop if you want to. Prime factors, that's another one that goes along with what we've been learning. You will have access to Brain Pop through Clever, and so you can do that. Okay, I'm trying to adjust my brightness because it's got a little glare to it. There we go, better. Okay, so let me zoom in a tad bit. right, so we are going to find the multiples. Multiples are counting by a number, or it's the numbers we would get if we were going like 5 times 1, 5 times 2, 5 times 3, 5 times 4. Okay, so we're going to write the multiples for these numbers. All right, so it says to time ourselves for 1 minute, but Miss Collins is just going to kind of do this. Okay, so multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Okay, so that was pretty easy. All right, write the multiples of 4 starting from 20. Okay, so 4, 8, 12, 16, 20, 24. Oh, it said only to go to from 20. Okay, so 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80. Okay, so I'm going to stop there. So there's our multiples of 4 starting from 20. Really, we started from 4, but that's okay. Write the multiples of 6 starting from 36. Okay, so 36 plus 6, 37, 38, 39, 40, 41, 42. If you don't know them, you can do that. 48, 49, 50, 51, 52, 53, 54. Okay, 54 plus 6 is 60. 60 plus 6 is 66. 66 plus 6, notice my pattern here, 36 to 42. So we're going to go up a 10, and then we're going to have a 2. So 72. 72 plus 6 is 78. 78 plus 6 is going to be 84. 84, 85, 86, 87, 88, 89, 90. Okay, and I'm going to stop there. So we're counting by a number. We're going up 6 each time. Okay, list numbers that have 24 as a multiple. So if we're looking for numbers that have 24 as a multiple, what we're really looking for here are the factors. Okay, because the factors of 24 are the numbers that if I count by those, I will say 24. Okay, so if I count by 1, I'm eventually going to say 24. If I count by 24, I'm eventually going to say 24. If I count by 2s, I'm eventually going to say 24 when I get to 12. If I count by 12, I'm going to say 24 on the second multiple. If I count by 3, I'm going to say 24 when I get to the 8th multiple. If I count by 8, I'm going to say 24 when I get to the 3rd multiple. If I count by 4s, I'm going to say 24 when I get to the 6th multiple. So the factors are the numbers that I can count by to say 24. So those are the numbers that could have 24 as a multiple. Those are the factors. All right. Use mental math, division, or the associative property to solve. Use scratch paper if you like. Is 12 a multiple of 4? Okay. So if I count by 4s, 4, 8, 12. Yes, 12 is a multiple of 4. Is 4 a factor of 12? Yes, because 4 times 3 is 12. Okay. Is 42 a multiple of 8? Okay, so 8, 16, 24, 32, 40. 48. No, I don't say 42 when I count by 8. It is not a multiple. So it is also not a factor. If it's not a multiple, it's not going to be a factor. They are very closely related. Is 84 a multiple of 6? So let's do 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72, 78, 84. Yes, eventually I would, if I counted by sixes, I would say 84. How many does it take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It takes 14. So 6 is a factor. The factor pair here would be 6 times 14 equals 84. And if I counted by sixes, I'm eventually going to say 84. Okay. Can a prime number be a multiple of any other number except itself? No, because prime numbers have no factors. They cannot have any other multiples. So because prime numbers have no factors, they only have one and their self, like 11. Okay, so if I said 2, if I count by 2s, I'm never going to say 11. If I count by 3s, I'm never going to say 11. If I count by 4s, I'm never going to say 11. Because only 1 and 11 are the factors. All right. So we need some colors. Now I'm going to look. We need red and green. Getting her colors ready. And blue. Use this one. Okay, so we're going to do some things here. Circle in red the multiples of 2. Okay, so we're going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 4, 6, 38, 40. And now I notice the pattern. It's these even rows that I'm going to circle. So I'm just going to go through and circle them. Oh, I did that wrong. You know, man. I wish I had a whiteout, but I don't. So, I'm just going to make a new little 95. My 95 gets a new little number here. Sorry about that. There we go. Cover that thing up. Okay. 95. Did not mean to circle you 95. Okay. Now it says shade green the multiples of 3. So, and it says shade, not circle. So I'm going to do like this. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Do y'all see this diagonal pattern that's happening? Do y'all see that? Diagonal pattern? 33, 36, 39, 42, 45, 48, and every other one is a multiple of 2, not a multiple of 2, multiple of 2, not a multiple of 2, multiple of 2, every other one, not a multiple of 2, multiple of 2, not a multiple of 2, multiple of 2. And my diagonal is definitely happening here. I've got like stripes And I'm using Christmas colors apparently. Every other one, it's like even, odd, even, odd, even, odd. Sorry you hear my girls. You probably hear them. Okay. There we go. We've got the green ones marked, and you can clearly see this diagonal pattern there. Okay, and so now we're going to do blue, the multiples of 5. Okay. So if you, okay, let's talk about this first before we go on to the blue, to those. Okay, so when we do our 2s, what are the values for the 1's digits? 2, 4, 6, 8, 10, which is a 0. We're only looking at the 1's. 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, 0. So if I am a multiple of 2, I am going to end in one of those digits, always. If I am a multiple of 2, that means I'm also even, and that also means I'm a multiple of 2. So if it ends in a 2, 4, 6, 8, or 0, it's a multiple of 2. All right, let's add up the multiples of 3. So I've got 1 plus 2 is 3, 1 plus 5 is 6, 1 plus 8 is 9, 2 plus 1 is 3, 2 plus 4 is 6, 2 plus 7 is 9, 3 plus 3 is 3, 3 plus 6 is 6, 3 plus 6 is 9. If I add up the 3 multiples, I get a number divisible by 3, always. So let's just try 156. Okay, let's try 156. If I add that up, 1 plus 5 is 6, plus 6 more equals 12. 12 is divisible by 3, so 156 is divisible by 3. Go, Rusty. Girls, call Rusty. I'm recording. Okay. All right. So now let's look at the blues. Sorry. I'm closing the door so my dog doesn't think it's time for me to walk him. Okay. Blues, multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. Now I get to color that one. It's not coloring very good. 95, 100. Okay. So for my blues, they all end in a 0 or a 5. If it's a multiple of 5, it ends in a 0 or a 5. Okay, now it says put an X over my 10s. So my 10s are all these down here. And my 10s always end in a 0. So they all end in 0 if it's a multiple of 10. All of them are going to end in a 0. Okay? So what we're doing here, the reason we're doing this is we're creating some rules. And these rules are called divisibility rules. Okay, so rules so that I know whether something is going to divide by something or not. So I'm going to go to Google real quick and then we'll come back to that. But let's go here and we're going to go divisibility rules. Okay. All right, and here we go. We could do either one of these, but I'm just going to pull up this one. Okay. Apparently, oh, let me go back because I liked it better. I liked it better on the other one. Okay, so divisibility rules. This is on Amazon. So apparently you can buy it, but I just want to show you. 2. If the last digit is even, then it's divisible by 2. If the sum of the digits is divisible by 3, then it's divisible by 3. Let me see if I can. There we go. Let's see if I can pull this one up and make it big. Here we go. Zoom. There we go. Okay. So if it's got 2, 4, 6, 8, or 0, then it's divisible by 2. If the sum of the digits is a multiple of 3, then it's divisible by 3, like we just did. We didn't do 4, but 4, if the number formed by the last 2 digits is a multiple of 4. So like think if I have a number in the thousands place. If the tens and the ones is divisible by 4, then it's all divisible by 4. 5, if it ends in a 5 or a 0. 9, if the sum of the digits is a multiple of 9, then it's divisible by 9. 10, if the last one is 0, then it's divisible by 10. 25, if the number formed by the last 2 digits is 0, 0, 25, 50, or 75, then it's divisible by 25. And then of course 100 is a 10, so it ends in a 0, but for hundreds it would be double zeros. So these are just some quick ways to kind of, I'm going to go back to my ladybug, and you can see I just Google searched this. They're all over. There's divisibility rules on here where you can, there we go, look at these things, okay? So that's what this chart was just about. And so we just did divisibility rules for the multiples of 2, the multiples of 3, and the multiples of 5, and the multiples of 10, really. So we just found those divisibility rules. Tomorrow we're going to go into those divisibility rules even more. If you have any questions about your exit ticket today, do not hesitate to get back on with me. Thanks.